Hey there, this is a little video about the mole. Um, we're going to take a couple of examples and present it so that you are clear about what the mole actually means. So the first thing we want to talk about here is values from the periodic table. So remember that when we're looking at an entry from the periodic table, that something like this refers to the atomic number. And you might remember that that is the number of protons. You should remember that. This refers to the average atomic mass. And really, in this unit, the most important part of that is the atomic mass part, right? So for most purposes, we're going to drop the average kind of concept, right? And the thing that you want to remember here is that number, specifically we're looking at nitrogen right here, 14.01, is a mass, just like atomic mass implies, and that value of 14.01 is the mass of what we refer to as 1 mole. Anytime we are talking about values from the periodic table, we are always talking about the 1 mole, right? So in this case, nitrogen is the substance we're talking about. 14.01 grams is equivalent to 1 mole. And what exactly does that mean? Well, 1 mole is going to be a certain number of nitrogen atoms. And in this case, we are talking about atoms. So it's 6.02 times 10 to the 23rd, which is a large number. And in this case, as I said before, atoms, right? So the mole will always be this way. In other words, it will always be that 1 mole is indeed equivalent to 6.02 times 10 to the 23rd of something. And if we were talking about another element on the periodic table, such as krypton, then we would be using a different number. Specifically, we would be using 83.80 grams. Since krypton is a monatomic atom, we would still use the term 6.02 times 10 to the 23rd atoms. But in this case, what we would say is that the mass of this would be 83.80 grams. All right, so if we were talking about something like nitrogen gas, which we remember, by the way, is a diatomic particle, then what we would have to use is we would have to talk about 2 of these nitrogen atoms, right? So in other words, we would have not only 1 nitrogen atom in there, but we would have a second nitrogen atom in there as well, right? So what that means is that when we're going to write a statement pertaining to something like N2 gas, that again we would want to say one more time that this is definitely going to be equivalent to 1 mole, and that 1 mole is still going to be equivalent to 6.02 times 10 to the 23rd. However, instead of talking about atoms, we're now going to say that N2 gas is an example of a molecule, right? So sorry if that went off the page right there, so I'll just emphasize that this is an example of a molecule, and this is an example of an atom. So actually, these are examples of atoms, right? So in the end, the left-hand side of this equation, which is sort of the big thing I'm after here in this little video, is that you need to calculate that mass. You can't just read it off the periodic table because there are 2 nitrogens in there. So of course what we're going to do is we're going to add the two 14.01s together, and we're going to get 28.02 grams, and that is something that we refer to as not just an atomic mass, right? But this is what we are going to call a molecular mass, because it is a molecule, or sort of the catch-all term that is very helpful to use is molar mass. So molar mass can be defined as simply the mass of 1 mole, and of course the mass of 1 mole will always be different if we are talking about different substances, right? All right, so that's my quick overview of what we mean by the mole in relation to the periodic table. Thanks.